It's that time again. It's math with Mrs. Peters, the crazy cat lady at Pine High School, and today's topic, domain and range. Before we get started, I want to talk about a number line. We have a horizontal number line called the x-axis. Right? Somewhere in the middle is the number 0. We don't always graph it, but it's there. And as we move to the right, our numbers are getting bigger. And as we move to the left, our numbers get smaller. For example, -10 is smaller than -2, while 2 is smaller than 10. So, with that said, that's our horizontal number line. I want to represent the same thing when we are talking about the vertical number line. Okay? Getting bigger is going up, getting smaller is going down. And that's an important concept that we're going to have to be using. So, let's look at some problems. I want to talk about graphing, and we're used to graphing on the number line. Okay, greater than is this symbol. Okay, less than is this one. Greater than or equal to includes the equal sign in it, and less than and equal to includes that sign. Okay, when we graph greater than and we use an open dot for both of these on the endpoints, and greater than or equal to requires us to have a closed dot because we're including the number that's the endpoint. Interval notation, we use parentheses. Okay, for both of these guys, they use parentheses around that endpoint. Okay, whichever way it has to go. And we use brackets on our endpoints to tell us that that is an included dot. For example, if I had this picture here, I have a closed dot and I have an open dot and I have an interval in between. Well, now that I have it graphed, it's real easy. Open dot means a parenthesis at -9. Okay, a closed dot means a bracket at 3, and I'm including everything in between. So my actual answer in set notation or interval notation would be parenthesis 9 comma 3 bracket. That's the interval that we're going to be talking about in the particular graph that I've just given you. Okay? Because I'm going to ask y'all to write your answers in interval notation. Right, so we have an odd degree positive coefficients. Look at these three. They all have odd degree positive coefficients, and you're probably getting sick of looking at these graphs because they're the graphs that I've used now in at least 2 other videos. Now, I told you the domain is always all real numbers. Well, that means I'm going from negative infinity, far to the left, to positive infinity, far to the right, and they get parentheses. That's going to be true for right now until I tell you otherwise. Okay, your domain, unless there's some reason why it has a hole in it, is always going to be all real numbers, and you're always going to write it as negative infinity to positive infinity. Now the range. Well, for an odd degree positive coefficient, that's a polynomial, right? Our range is going to start in the lower left. It's going to start way down low, negative infinity, and it's going to go up, and that's going to be positive infinity. And you're going to notice that that is true for all 3 of these that I just drew out. Okay, so that if you are an odd degree positive coefficient, your domain and range looks like this. Now, I'm going to group these. I'm going to copy it because what did I say just a few minutes ago? I told you that no matter what, I'm going to tell you that your domain is always going to be all real numbers. That was a whole lot easier doing it that way. Okay, now my range changed. I'm going from high and moving to low. So that means I'm going to be starting in the high and moving to the low. Starting on the high, moving moving to the low. Starting on the high, moving to the low. And there's my domain. There's my range. Let's look at one of these even degree positive coefficients because our range is going to be different. Now we have the same domain. Okay, it's still infinity to infinity because we're still using all the x-axis, but our range changes. And this is where we have to pay attention to how low does it go. All right. Well, this one's lowest point is +1. So I'm going to start at +1. And it looks like it's included because there's no open dot there. So I have to include it. And then I'm going to positive infinity. Okay. Look this next one. Its lowest point looks to be right here. That corresponds with -4 on my graph. It looks included because there's no open dot. And I'm going to positive infinity. Look at this last one. Looks like my lowest spot is right here. Okay. What does that correspond to? That corresponds to 0. It looks included, no open dot, no reason not to include it, and it goes on to positive infinity. Now, one last one. Even degree, negative coefficient, the opposite of what we just did. Now, again, my domain is all real numbers. And what we have to pay attention to is how high we have gone. So I want to know how high I am right here. That looks to be about 5.5. Okay. Now I wrote it on the other side, didn't I? Well, because that's the highest point it's going to get. The lowest is going to be infinity. Okay, let's look at this one. That's the highest point my graph is going to get. Okay, so that is -1. It's included, and I'm going to be coming up from infinity to get there. All right. Here, this one is at 0. It's included, and again, I'm coming up from infinity to get there. And that's the end of today's lesson. Y'all, write your notes, put them down on paper, come see me. Y'all have a good night, and talk to y'all later. Bye.